products in our new platform, including some of the newer analytics capabilities, and that's what I was going to talk about today. So, thanks for showing up and preferring this air-conditioned room over the blazingly hot pool outside. I want to talk to you a little bit more about analytics, the A word. So, how many of you have had their manager or their CEO or a consultant suggest that they do some analytics? So, analytics is everywhere, and I'm not going to contest all those interesting statements that analytics is the way to derive value from your data, or it's how you turn insight into action, or how you get the insights in the first place. So that's all true, but what does analytics really mean? What does it entail? What are the actual real activities in there? So if your manager asks you to do analytics, where should you start, or where can you start? So I'd like to explain that with an analogy. So I'd like to see analytics as sort of the same thing as traveling. So data is the world, and analytics is traveling that world, and it's kind of going about. And just like with analytics, if your manager says that you should travel, that could mean many things. So you could go many ways. So let's give it a try. So this is traveling. This is exploring. So if you're an adventurous type, if you have some hiking shoes, you can just step outside and start walking and start to try and get a feel of what the land feels like. Try and make it all the way up so that you have some nice views, and just get to know the terrain in all of the detail that it really that it exists. See the data, see the world how it really is. And if you're in good shape, you can cover quite a bit of distance. But probably it's going to end somewhere. So if your name is Robert Nagel, you may make it up to 100 miles, but not everybody may be able to walk as far. So in the world of analytics, that means exploring your data, trying to get a feel of the distribution of the data, what is in there, are there any particular strange things, look at the low-level detail, use some very simple tools like a SQL prompt and do some SQL querying, or look at the raw data files. And that works, and that gives you a really good sense of what the data is like, what the actual data is like. But you can only cover so much ground. You can't read a gigabyte of text in one day. Just like you can't walk from coast to coast here in one day. So that's exploration. It's got its limitations, but it's a nice way, a down-to-earth way of understanding what your data is all about. Move forward. This is not here. Unless something changed due to a hurricane nearby. But this is another type of traveling. So this is staying at a resort where you have a nice pool, where you have nice views, where maybe they offer some excursions or some other activities in which you can get a little feeling. But the essential difference between this and exploration is somebody made some choices for you. Somebody decided, like, hey, this is a good spot here. If you put your bed here, you can have a magnificent view over the ocean, or if I put a parasol here, you'll be nicely in the shade and you can rest a little bit. So, or if you walk this way, you arrive at a buffet which has pretty much everything you can think of, including some local fare. So there's somebody else that kind of prepared the data a little bit for you, that prepared your trip for you. So that's in the analytics analogy, that means somebody kind of massaged the data or made some selections of the data for you. Maybe they aggregated some things for you. They made it convenient for you to look at. You didn't have to put on your hiking shoes and get sweaty. They made it convenient for you. So it's like dashboards. It's an analysis environment in which you can point and click without having to type outright SQL or do any real complex stuff. So it's very valuable because you can see a lot more. Well, you can see farther in this diagram than possibly in the previous one. But essentially, you're being shown a manicured subset of your data. So that used to be called business intelligence. Analysts, because they have to invent new terms every 2 years, otherwise they are out of work. They try to give that newer names, but essentially what it comes down to is dashboarding, ad hoc analysis of a sort of predefined universe of your data. So that's the second sort of broad category of analytics activities. Now, let's move on to the next one. And that's, so if you're traveling and if you're enjoying, and if you're enjoying the place, if you're having a good time, you may find a couple of things that, well, I want to do this at home. So this is a nice cocktail recipe. I want to have that same drink at home. Or you go to a souvenir shop and buy something to take home and be useless there as well. So, but I thought the cocktail was a little bit more useful than the souvenir, so that's why I didn't put up an image of the souk in Istanbul. So the idea here is that you get some experience while traveling, and you want to take that home. In the world of analytics, that translates into predictive analytics. That translates into modeling. So you try and identify a model, you try and identify a pattern in the data, in the place you're visiting, and you try and take that home and kind of apply that at home and make that useful at home. Obviously, the more cocktails you drink, the more likely you are to be able to reproduce the recipe appropriately, although there's some sort of a trade-off in the particular cases of cocktails. But essentially, the idea is you learn something somewhere, and you want to take it home and be able to apply it in your day-to-day work. So that's yet another activity in the broader umbrella of analytics. Now, if you want to travel a little bit further, this is the next frontier. So if you're into traveling where nobody has gone before, you might as well launch a rocket and send it off into space and try and explore places nobody else has ever been. For example, the Voyager mission is probably somewhere around here by now. It's been out there for 40 years, and it's been gathering data, and it's been kind of getting the lay of the land. It's that very exploratory thing. It's that down-to-earth thing, putting on your hiking shoes. But you could also imagine that people like Richard Branson and Elon Musk are talking about building a resort on Mars and providing you with kind of set trips. So that's that business intelligence style activity. So that's going somewhere and then having a nice time there in a place that has been kind of prepared for you. And then the third activity, the finding useful patterns out there and taking them back home, you could think of, for example, an anti-stick pan, a Tefal pan, the Teflon coating on there. That's something that we learned from space travel and space experiments. So that's where they learned how to develop that material. So whereas it sounds like it's a big leap, the activities for, just give it a name, big data for that next frontier, that less familiar type of data, the techniques are not totally different. The approaches are not totally different. You may need to think twice about the tools. You can't get here with just your hiking shoes. But the idea of what you're going to do there is pretty much the same. You're going to try and find some distributions in that data. You're going to try and present a good overview for your manager, or you're going to try and learn something there so that you can apply it back home. So that's I think, enough in terms of fancy pictures, but it was just sort of a way of giving you more of an overview of different types of activities that you could find in the general term analytics. So now let's take a look at what that means in actual workflows, in actual tools. So if you want to do analytics, the first step obviously is kind of finding the data, capturing the data that you want to look at. So capturing and storing is sort of a first activity for which you would need tools. So it's not analytics per se, but it is a starting point. And that means capturing the data typically starts in a very raw format, but eventually you can also massage your data in a more curated format so that it's more ready for analytics. But essentially the goal of this capturing and storage stage is making sure that you can capture the data so that it is available for doing subsequent analytics. There's a lot of different technologies out there, from raw to more specific. On the raw end, you have Hadoop's distributed file system. There's some NoSQL databases that do a terrific job at capturing data in that very raw form. Then there's databases like our own database in kind of a more relational, classic relational databases that also allow you to kind of store data. Then they make some assumptions, or they force you into, for example, a tabular format in the case of a relational database. But it is more convenient for the analytics tools on the other end to get at that data. So you're kind of there's this sort of a trade-off in capturing the rawness and making it available for subsequent analytics. There's a couple of solutions out there that are also specifically about capturing and storing data. For example, Splunk is a solution for capturing machine-generated data, such as log files, audit files. So it's very good at precisely that scenario, and also does a couple of things more that are at a higher level of the analytics stack, if you wish. Typical challenges in this kind of array of tools are volume, velocity, variety of data, so the classic V's of big data, and then providing that flexible access to your data. So storing data is one thing, making it useful is another thing. And then to get on to that, making it more useful, let's look at another category of tools that are not just about capturing the data and persisting it to a disk, an on-disk format, but about transforming it from that very raw data which it arrived in into a format that is more appropriate for analytics. So that's what I call data processing tools. So transforming it into analytics-ready formats. There's a couple of frameworks out there, and for those of you that were here in the previous session, you've heard Anton talk about Apache Spark. Apache Hadoop's MapReduce paradigm is yet another tool that's actually kind of an old predecessor of Spark, if you wish. I'll be talking a little more about that tomorrow at 2 in a flash talk. But there's also, ETL tools are also fit in this area. So getting data from that raw format in a curated format doesn't necessarily have to happen in the same systems. You could have like some very raw file storage on this end, and you could have a nice enterprise data warehouse on this end. And then the processing is all about getting the data from that one side into other, and that's what people call ETL. Oracle Data Integrator, Attunity, Informatica, SnapLogic, which is based on Spark, are a couple of very nice tools that provide ETL capabilities. But you could also do some of that with a database. You could write stored procedures, and probably most of you have at some point in your career written stored procedures to get data from one format into another because that other format was needed for a subsequent step. So again, there's this trade-off between flexibility and scalability and power or expressiveness. So for example, these frameworks like MapReduce and Spark, they require you to code, so their audience are developers, whereas ETL tools are primarily are more oriented towards business users or users who prefer to work with the mouse rather than the keyboard. But then looking, for example, at that stored procedure example, if you write a stored procedure that translates the CSV file into a table format, that may work well on a CSV file of a couple of megabytes, but if you grow that to a couple of gigabytes that is on a distributed file system, then maybe your small handwritten code may not be as efficient as it could have been. So that's where the flexibility of SQL or of writing a stored procedure in COS may not necessarily match the scalability requirements that you may have when looking at larger data sets. So data processing is kind of getting it really ready for analytics. And then the proper analytics starts here with exploration tools and business analytics tools. I put them together because the line is a little thin. You have these backpacker resorts that are somewhere in between our exploration down to earth style traveling and the upscale resorts. So one thing that's important here is that it's not a set process. You don't start by finish capturing the data, then do the processing, finish the processing, then do the exploration, finish the exploration. No, it's kind of an iterative process. And sometimes through the exploration, you learn that there's maybe some noise in your data. There's maybe some things that weren't really appropriate. So you go back to your data processing, get rid of the noise, and you kind of you iterate back and forth, you jump back and forth. Or you may find that there's a couple of interesting subsets of your data that may be good candidates for building a universe and exploring in the analytics in the BI on the BI side. So finding opportunities for data refinement and further analysis is also a core aspect, a core goal of these categories of tools. So on the exploration side, just the database management system is really where you can get your hands dirty and try and identify interesting pieces. On the analytics side, there's more these sorts of point-and-click solutions like Tableau, ClickView. DataMirror is also interesting because it's also based on Apache Spark, so natively supports very large data sets. The classic mega vendors are also present in this, very present in this area. But again, we have that challenge between how can I make a very usable tool versus how can I make a tool that works on very large data sets. And that's where something like DataMirror has done a rather good job in kind of offering a nice UI on top of something that is inherently, that's implicitly big data. So finding that flexibility through balancing pre-definition, which is the analytics side, with the flexibility that is inherent to exploration is a challenge in this area. Support for semi-structured and structured data. So many of these do a really good job at the structured data, but the unstructured data is sometimes only covered in something that's really at the bottom of the price list and totally unconnected to the other pieces. So that's also something that's not as trivial. So on to the next stage, machine learning. So after you've identified pieces that are interesting, after you've found your favorite travel destinations, your favorite bar at your resort, you can start trying those cocktails. So that's the machine learning part. So that's trying to identify patterns, correlations that can help you in your daily life, in your regular business operations. So identify correlations between input features and a particular column or a particular data field that is your desired outcome that you'd like to predict. Or maybe that's a less sexier part, but identifying derived features, so just trying to make new data out of the data that you already have, but new columns that may have a better predictive value for getting at those outcomes. So there's some pretty impressive frameworks out there, such as R, Spark Machine Learning, SystemML, very nice abstraction layer above the actual machine learning implementations, Python, Scikit. So those are more, I wouldn't say developer tools, more data scientist tools for people who really like to write the code. And then there's also more UI-like products, such as SAS, SPSS, R Server as kind of something that's built on top of R. So the challenge there for those tools is to try and find the balance. Because if you look at these frameworks, like R has thousands and thousands of packages that implement specific algorithms. Some were written by very smart people. Some were written by people who would like to become very smart by writing more of them. But they're typically rather complex algorithms. And abstracting that complexity for you and still giving you a productive user experience, that's sort of a trade-off that these products try to find. And also, obviously, it's important to be able to optimize your computations on large data sets. So that's, for example, where R is perhaps a little handicapped in its original form because it has to all fit in memory on one machine, whereas certain other kind of evolutions of R, like Revolution R, which was acquired by Microsoft, have a better story because they allow you to scale horizontally. So that's the machine learning task. And then in order to close the loop, for those of you that were here in the previous session, you've already seen how Anton did that. So once you've found your model, once you've been able to express that particular pattern in your data, taking it back home means kind of capturing it in some format that you can kind of translate from the analytics language, analytics tools, into your daily production tools. So there, the PMML standard is really the single best example of the opportunity to close that loop. Okay, now what does that mean for InterSystems? If you look at the recurring themes in the previous overview, is the diversity of the tasks is daunting. So there's no single solution that can possibly capture data, process data, explore data, analyze data, machine learn your data, if that is a proper combination of a noun and a verb. But you just can't solve it with one tool. So you need a a couple of different tools that address specific pieces of that workflow. So it's key to have a platform that is open, that allows you to combine those different tools and gives those different tools good access to your data. And the fact that you're able to choose different tools can also help you address that usability versus flexibility trade-off. So an open platform is essential to being successful. Then that storage layer, it was kind of hidden at the bottom, or not really hidden, but it's really important because all of those layers or all of those activities that I put up at the top of the diagram, they all tie back, they all connect back to that layer at the bottom. So it has to be a flexible storage layer that allows you to access your data in various formats, in various models, and make sure that while you're doing that, that it does that in an efficient fashion and allows you to leverage the power of that platform. Because horizontal scalability is another important must. So how do we solve that? Obviously with the InterSystems Iris Data Platform. So with the InterSystems Iris Data Platform, we're really keen on giving you an open analytics platform, so a platform that allows you to work with the tools that you like, with the tools that you know, with the tools for which you have experience or for which you find broad information out on the market, while still ensuring that you can connect to the data in the most efficient way possible. So we will include a couple of embedded technologies like the ones listed in blue, but we will also, through support for industry standards, orange, and support for third-party tools that we know are good at what they mean to do, we want to give you that open analytics platform. So let's zoom in on the particular elements of this diagram for a bit. So first and foremost, the database. I already mentioned it a couple of times. That database is really where every different tool is going to connect back to. So that has to be a flexible storage layer that is also a scalable storage layer. So as you know, InterSystems has always excelled at vertical scalability. Remember Robert Nagel's classic citations of ever better performance metrics at Global Summit. So that's where we have a proven track record of taking advantage of ever better hardware. What we're adding on top of the ECP application server capabilities that we already supported in the past is now also sharding as a means to horizontally scale on the data side, on the bottom side of your platform. And to offer you great connectivity with InterSystems Iris Data Platform, we've also focused heavily on improving the capabilities of our JDBC driver. So we'll make sure that your JDBC driver can take advantage of a sharded topology when it's pumping in data. We're making sure that if you're connecting from the same host as where the database is running, that you don't have to pass the data through the JDBC protocol, but that we can just read directly through shared memory optimizations. And also, we know our database best, so we can kind of optimize the data transfer between the data as it's stored in globals on disk and your JDBC client by using what we call fast data transfer. That just exploits that and avoids having to go through the JDBC standards, but in a transparent way. So it's still according to the JDBC standard, but we're taking shortcuts in between. Okay, on top of the database, technologies that we offer ourselves that really fit into that analytics family are our two embedded technologies that we've had for quite a while, and have been there to allow you, when you are building applications, to easily access these capabilities without having to rely on third-party software. So InterSystems Iris Business Intelligence, which was formerly known as DeepSea and will still be known as DeepSea for quite a while, as I'm sure you can imagine, allows you to define multidimensional cubes and work with dimensions, query measures, and then build KPIs, allow you to do ad hoc analysis, build those dashboards, so that resort-style analytics that we talked about in the beginning. And then InterSystems Iris Text Analytics, including our INO technology, helps you to identify concepts and their context in potentially vast volumes of natural language text. So those are the two main technologies that have been in our platform for quite a while already, that are embedded in there and allow you to kind of do particular pieces of analytics. But as I hope I was able to show you in the first half of the presentation, there's a lot more out there. And that's why we're really making sure that we are open to these other technologies, starting with the InterSystems Iris Apache Spark connector. Some of you were in the previous session by Anton. Anton is no longer here because he is now in the Experience Lab presenting a hands-on session on Apache Spark. So that runs tomorrow and on Wednesday again. So if you're interested in rolling up your sleeves and kind of taking a shot at Spark, I warmly invite you to go and see the reception and register yourself for the Experience Lab. So what is Apache Spark? Apache Spark revolves around this abstraction of a data set. An abstraction that kind of allows you as a developer to work with an object that represents the data in the background. That data in the background can be stored in a vast Hadoop cluster, can be stored in a sharded cache cluster, can be stored pretty much in any other format. For you as a Spark developer, it looks the same. It's just the same data set, which has nice high-level abstractions that allow you to filter data, that allow you to select particular features or apply transformations to that data. And Spark is just very efficient in executing those operations, kind of combining that combining multiple operations and before it sends it to the different Spark worker nodes. So it comes also with an interesting set of libraries, including machine learning libraries, which is what is going to be used in the Spark Experience Lab. Now, why is Apache Spark such an interesting candidate to work with for us at InterSystems? Because Apache Spark is not focused on one specific storage provider, which is the handicap that Apache Hadoop's MapReduce data processing framework has. So where MapReduce is really tied to Hadoop's distributed file system for storing intermediate results, Spark tries to abstract that and provides vendors like us with a pluggable API, a data source API that allows us to tell Spark what the thing underneath is capable of. So we can tell Spark that, hey, we're a relational database. So if you have some filter criteria, just send them to us, and we'll apply them at our level, and we may be able to leverage some indices underneath so that we don't have to pass all of that data over the network up to the Spark workers. It also allows us, that data source API also allows us to tell Spark that, hey, the data that you're reading is actually already distributed across a number of nodes. So your nodes, your Spark nodes, can connect directly to my data nodes and thereby massively increase your throughput. So those are a couple of things that data source API allows us to do and that we're now taking advantage of. And then it's the Spark Catalyst compiler that takes advantage of that to push the computations right to the data. So what did we add with our Spark connector? So we've got our read and write API, so it's plug compatible with the regular out-of-the-box JDBC connector that Spark provides, but we are making it a little nicer. We've got a couple of nice additions that we added for convenience. We're pushing down everything we can to the database. So we're starting with filter and select operations, and we're looking into also pushing down aggregations and other computations in a future version of the connector. And that's probably the most important one, we're leveraging the distributed database layout in case you're working with a sharded cluster so that you can take advantage of all the machines without having to bottleneck through your data master. So I'm not going to go into too much detail about this part because there's a very nice session by Jeff and Harry about sharding that's, I think, taking place somewhere next door, but it's going to run again tomorrow about what sharding is. But essentially what you get with the JDBC connector that comes out of the box with Spark is the possibility to open a JDBC link to your database. And the classic JDBC connector doesn't know anything about cache, so it doesn't know anything besides that it has the URL of your master or the IP address of your master node, and it just connects with a single connection to that master node. And then all of the data coming from your shards at the bottom has to go through the master node, through the single Spark worker node that opened the connection in the first place. Whereas if you're looking at what the Spark connector adds, is it allows you to have, the Spark connector will tell Spark, hey, the data is actually split into multiple nodes, so you can connect to those directly. It's transparently taking advantage of the JDBC connector, the JDBC driver enhancements that I talked about previously. So these pipes are a lot bigger than this one. And also, it knows that if your Spark node is on the same physical host as the shard, we'll make sure that you only connect to that one, and thereby save the network hop. So we're leveraging that co-location. We're making sure that you can connect locally to the extent possible. So that's one of the third-party technologies that we're now supporting in this open analytics platform approach. The next one is a standard called PMML. I already described it a little bit. It is actually the one that helps us cross the border between transactional systems, where your data really is, where your where your credit card transactions are taking place. So this is, imagine that you're working at Atos Origin, credit card service provider, and you have like millions of credit card transactions arriving every day. Then this is probably a rather crucial system that you want to be careful about. So it's generating a lot of data, helpful. So you can export that data into your analytics environment and apply machine learning on it to eventually come up with a model that predicts which credit card transactions might be fraudulent ones. But then you have that model sitting here, and you have your credit card transactions sitting here. So how do you get your model in an efficient way from this side to that side? Because calling from here to here for every single transaction is just not possible. It's not feasible, because this is built for batch-oriented workflows, and this one is built for real-time workflows. So that's where the PMML standard comes in. It allows you to, irrespective of the particular implementation of your modeling tools, it gives you a standard format to express your model, and then on the transactional side, there's a number of vendors, data platform vendors, and niche vendors that implement model consumer technology that can just look at this XML file and give you responses for individual records that, for which the prediction needs to be made. So how does that work with InterSystems Iris? So we have model consumer, PMML consumer support. So if you load a PMML file into InterSystems Iris, we will generate native cost code that contains the implementation of the model, so that can run within your transactional environment without having to call out to any analytical system sitting somewhere in a data scientist's ivory tower. So this is something that's actually already been part of Cache for a couple of years now, but we're expanding the scope of the standard, of the part of the standard that we're supporting in these releases. So PMML support, great standard for predictive modeling. Now, the last piece of the Open Analytics platform that I wanted to talk about is the UIMA integration. So UIMA is yet another standard, this time in the area of unstructured information processing. So the acronym is Unstructured Information Management Architecture. So if any of you have ever worked with unstructured data, you probably have seen quite a variety of tools. There's many different tools. Some are provided by academics, some are open source, some are commercial ones. And the thing that binds them all is that they're different. So if you are trying to work with more than a single NLP technology, NLP, natural language processing, if you're trying to combine more than one technology, you'll often find yourself spending quite a lot of time making sure that you have the inputs for tool one right, then get the output of tool one into a format that's compatible with tool two, and then aggregate the outputs. So you're doing a lot of custom code writing in trying to wire those together. So that's where the UIMA standard comes in. It provides interoperability between these unstructured information processing tools. So rather than having to worry about how can I combine the inputs and outputs of these various tools, it just gives you a standard contract for how these tools should behave. And as a model, as a consumer, as a solution developer, you can just develop against that interface and you're good. You don't have to care about the particular implementation craziness of these various NLP tools. And if you are an NLP tool developer, you don't have to worry too much about adoption. You can just implement the interface, and then all of the solution developers will be happy because they can just develop against a single interface rather than having to worry about your own craziness. So what have we done to support this standard, which, by the way, also has interesting scalability advantages because it can parallelize the work if you wanted to. So what have we done? We've married the idea of this processing pipeline with the concept of a data platform, which means that we allow you to, if your data is already in our data platform, that we give you the plumbing-less option to immediately send that to any UIMA-based workflow. So you only have to give the address or give the descriptor of your UIMA pipeline, and we will do the rest. We will make sure that your data arrives there. And then at the other end, that once the annotations, once the output of your NLP tools comes back, that it gets stored in your data platform again in a SQL queryable way. Because the UIMA standard by itself is only about the processing part and doesn't say anything about where the output eventually should end up. So that's good if you're interested in just one document by one document, and if you like a very verbose XML format, which is the only output feature that UIMA out of the box offers. But it's not good if you want to do some analytics. It's not very helpful if you want to be able to query across documents. So that's where we have a fully SQL-compatible annotation store that we're adding in our UIMA integration. And then as a third part of our support for the standard, we're offering, we've made our INO engine UIMA compatible. So now, if you are a solution developer and if you work with other UIMA tools, you can just plug in INO as one of the tools that fit that standard, that fit that interface. So that was in a bit of a rush, an overview of what we're after with our Open Analytics platform. So it is the kind of analytical strategy for the InterSystems Iris Data Platform, and it's based on on support for three styles of analytics, if you wish, or technical styles. So through embedded technologies, INO and DeepC, that have been in the product that many of you know and have used and trust. For more exploratory tasks, we're integrating through dedicated connectors with certain third-party technologies. We've now focused on Apache Spark in this release, but we're looking into several more. And we want to make sure that those tools can get access to the data in the most efficient way possible. And we're also focusing as a third dimension on industry standards that are relevant in the analytics area that allow you to work with other tools that honor those standards and just be more productive without having to worry too much about tools and things working together. A couple of related sessions that I'd like to recommend. So there's a couple about the InterSystems Iris database. So that's the one I mentioned by Jeff and Harry, which is taking place next door, but it's running again tomorrow at 3 p.m. John Payne is presenting a nice one about use cases for sharding. So also including a couple of use cases from the financial services industry. Stefan Whitman has a flash talk about the advancements in the JDBC driver, how we've massively increased throughput there. The Experience Lab, I already mentioned that, so that runs daily, presented by Anton. After the break, there's a session by a customer of ours, NetSmart, who will be talking about how they deployed INO and how they build a nice solution out of it. Tomorrow, also in this room, we'll have the Belgian Federal Police talking to how they used iFind to kind of build a federated search infrastructure, which is very impressive. And then Jos is doing another flash talk about the UIMA standard on Wednesday morning. So please complete the survey. Please visit the Tech Exchange and ask us questions so that we can share our enthusiasm for the new platform and this new strategy. And then thank you. And if you have any questions, we still have a couple of minutes left. questions?